Wormhole. How scientists found wormholes. A wormhole, also known as an Einstein-Rosen bridge, is a hypothetical connection between 2 points in spacetime that creates a shortcut through the fabric of spacetime. This idea was first proposed by physicists Albert Einstein and Nathan Rosen in 1935 as a solution to the equations of general relativity. But before we begin, please like and subscribe to our YouTube channel for such amazing and informative videos on how scientists found wormholes. Imagine two towns on opposite sides of a mountain. People from these towns would probably have to travel all the way around the mountain to visit one another. But if they wanted to get there faster, they could dig a tunnel straight through the mountain to create a shortcut. That's the idea behind a wormhole. A wormhole is like a tunnel between two distant points in our universe that cuts the travel time from one point to the other. Instead of traveling for many millions of years from one galaxy to another, under the right conditions, one could theoretically use a wormhole to cut the travel time down to hours or minutes. Because wormholes represent shortcuts through space-time, they could even act like time machines. You might emerge from one end of a wormhole at a time earlier than when you entered the other end. While scientists have no evidence that wormholes actually exist in our world, they're good tools to help astrophysicists like me think about space and time. They may also answer age-old questions about what the universe looks like. Because of these interesting features, many science fiction writers use wormholes in novels and movies. However, scientists have been just as captivated by the idea of wormholes as writers have. Researchers have never found a wormhole in our universe, but scientists often see wormholes described in the solutions to important physics equations. Most prominently, the solutions to the equations behind Einstein's theory of spacetime and general relativity include wormholes. This theory describes the shape of the universe and how stars, planets, and other objects move throughout it. Because Einstein's theory has been tested many times and found to be correct every time, some scientists do expect wormholes to exist somewhere out in the universe. But other scientists think wormholes can't possibly exist because they would be too unstable. The constant pull of gravity affects every object in the universe, including Earth. So gravity would have an effect on wormholes, too. The scientists who are skeptical about wormholes believe that after a short time, the middle of the wormhole would collapse under its own gravity. Unless it had some force pushing outward from inside the wormhole to counteract that force. The most likely way it would do that is by using what's called negative energies, which would oppose gravity and stabilize the wormhole. But as far as scientists know, negative energies can be created only in amounts much too small to counteract a wormhole's own gravity. It's possible that the Big Bang created tiny wormholes with small amounts of negative energies way back at the beginning of the universe. And over time, these wormholes have stretched out as the universe has expanded. While wormholes are interesting objects to think about, they still aren't accepted in mainstream science. But that doesn't mean they're not real. Black holes, which we astrophysicists know abound in our universe, weren't accepted when scientists first suggested they existed, back in the 1910s. Einstein first formulated his famous field equations in 1915, and German scientist Karl Schwarzschild found a way to mathematically describe black holes after only 1 year. However, this description was so peculiar that the leading scientists of that era refused to believe that black holes could actually exist in nature. It took people 50 years to start taking black holes seriously. The term, black hole, wasn't even coined until 1967. The same could happen with wormholes. It may take scientists a little while to come to a consensus about whether or not they can exist. But if they do find strong evidence pointing to the existence of wormholes, which they may be able to do by looking at odd movements in star orbits, the discovery will shape how scientists see and understand the universe. Another problem comes from instability. The predicted Einstein-Rosen wormholes would be useless for travel because they collapse quickly. You would need some very exotic type of matter in order to stabilize a wormhole, said Xu, and it's not clear whether such matter exists in the universe. But more recent research found that a wormhole containing exotic matter could stay open and unchanging for longer periods of time. Exotic matter, which should not be confused with dark matter or antimatter, contains negative energy density and a large negative pressure. Such matter has only been seen in the behavior of certain vacuum states as part of quantum field theory. If a wormhole contains sufficient exotic matter, whether naturally occurring or artificially added, It could theoretically be used as a method of sending information or travelers through space, according to Live Science. Unfortunately, human journeys through the tunnels may be challenging. The jury is not in, so we just don't know. Physicist Kip Thorne, one of the world's leading authorities on relativity, black holes, and wormholes. But there are very strong indications that wormholes that a human could travel through are forbidden by the laws of physics. That's sad. That's unfortunate, but that's the direction in which things are pointing. You can go into the future or into the past using traversable wormholes, astrophysicist Eric Davis told Live Science. But it won't be easy. It would take a Herculean effort to turn a wormhole into a time machine. It's going to be tough enough to pull off a wormhole. However, British cosmologist Stephen Hawking has argued that such use is not possible. A wormhole is not really a means of going back in time. It's a shortcut, so that something that was far away is much closer, according to NASA's Eric Christian. Although adding exotic matter to a wormhole might stabilize it to the point that human passengers could travel safely through it, there is still the possibility that the addition of regular matter would be sufficient to destabilize the portal. Today's technology is insufficient to enlarge or stabilize wormholes, even if they could be found. However, scientists continue to explore the concept as a method of space travel with the hope that technology will eventually be able to utilize them. You would need some of the most super advanced technology, Shu said. Humans won't be doing this anytime in the near future. Did you learn something new about how scientists found wormholes that you didn't know before? We hope you did. So, if you're interested in learning more amazing facts, make sure to subscribe to our YouTube channel and hit the bell icon to get notified by our new videos. Please like and share the video. Don't forget to comment your views on this. Thanks for watching to the end.